Hello and good morning, dear students. Welcome back to the online class. So we are still in exercise 8.16. Yesterday we have completed the question number 10, isn't it? And now today we are starting with question number 11. But before we start this exercise, let me tell you, since there is a change in the syllabus, the reduced syllabus, some of the exercise of indefinite integral has been reduced. So we are not taking those questions which were not included in this year's syllabus. Okay, so there will be a change in some of the questions. We are going to skip some questions. Okay. Number 11. The question is integrate 0 to pi by 2 under root 1 minus cos 2x. Now whenever I get this expression 1 minus cos 2x, the formula for cos 2x has to be clear. And this formula for cos 2x, which I am telling you, I have been given this formula from class 11 onwards, isn't it? So you must be clear with this formula so far. There are 4 formulas for cos 2x. First, the second, third, and then the fourth. Even we know if we have minus, then the formula goes for sine. If you have plus, the formula goes for cos, isn't it? So no doubt out here 1 minus cos 2x will be the third formula. 1 minus cos 2x will be 2 sine square x. So therefore, very simple, 0 to pi by 2 under root 2 sine square x. Square gets cancelled out and root over 2 is constant, which comes outside. So root 2, 0 to pi by 2 into sine x dx. Simple as that. So integration of sine x is minus cos x. So therefore, root over 2 within the box bracket minus cos x, it goes from 0 to pi by 2. Even minus sign you can take it outside. So therefore, minus of root 2. So use the upper limit minus lower limit, which means cos pi by 2 minus cos 0. Cos pi by 2 minus cos 0. So therefore, cos pi by 2, it is 0 itself, and cos 0 is 1, minus and minus plus, hence the answer is going to be root over 2. Please pause the video and note it down. Right, let's move on to the next question. I have 1 plus sine x. 1 plus sine x. Now out here I cannot use this formula. Okay, so but what I know is sine x, the formula for sine x is 2 sine x by 2 into cos x by 2. And 1 also we know, we can write it as sine square x by 2 plus cos square x by 2. So let us start. 0 to pi under root 1 will write as sine square x by 2 plus cos square x by 2 plus sine x as 2 sine x by 2 into cos x by 2 into dx. If you look at this properly, it is in the form of a plus b whole square. So 0 to pi a square plus 2ab plus b square. So sine x by 2 plus cos x by 2 whole square. Sorry, dx. Square gets cancelled out. So 0 to pi by 2. This is sine x by 2 plus cos x by 2, right, into dx. Now what we need to do, we need to integrate sine x by 2, cos x by 2 within the box bracket and then put the upper limit and lower limit. Okay, so integration of sine x by 2 is minus cos x by 2 divided by half. I hope you're clear why it is half, plus integration of cos x by 2 is sine x by 2 divided by half again. Okay, so 0 to pi. Pause the video, please copy it till here and move to the next part. I hope I can clear this as well. Please pause the video, okay? Now, 1 by 2 means 2, 1 by 2 means 2, so 2 is a constant. You can take it outside. See, whichever is a constant, I'm taking it outside. Okay, this is 2. And I'm writing sine x by 2 first, because it's positive, and minus cos x by 2 as second, and then 0 to pi. Now what you need to do, just put pi and minus 0 twice. So I'm using pi first, so sine pi by 2 minus cos pi by 2 in the first bracket. This is the upper limit minus the lower limit, the same function, lower limit. So sine 0 by 2 is 0, minus cos 0 by 2 is also 0. Let us simplify now. So this is 2 sine pi by 2, 1 cos pi by 2, 0. Sorry, this is cos 0. Okay, my mistake. Cos 0. And sine 0 is 0, cos 0 is minus 1. Close the bracket. Therefore, this will be 2, it's 1, 0, minus and minus plus. So this is 2 into 2, which will be 4. So this is your final answer. Pause the video and note it down. Not a difficult thing at all. We just have to integrate, okay, and put the upper limit minus lower limit. That's it. Okay, pause the video, note it down. Alright, we move to question number 12 part 1 now. Let's move to question number 12 part 1. Okay, so in question number 12 part 1, the question is this. Number 12 part 1, the question is this. Integrate 0 to pi by 4 sine 2x sine 3x dx. Sine 2x sine 3x dx. Now the moment there is sine 2x into sine 3x, product of two trigonometrical function in terms of sine, then remember we have to use this formula which we have already done in class 11. Isn't it or not? Multiple angles, submultiple angles, compound angles. So those formulas are this. 2 sine c sine d. The formula is cos c minus d minus cos of c plus d. Okay? So let us write this. So write 0 to pi by 4. Okay? But I need 2 out here, so multiply with 2 and divide with 2 as well. I'm keeping sine 3x as the first term and sine 2x as second term divided by 2. Okay, so now we can see it is in this form, right? So 1 by 2 is a constant. Integration 0 to pi by 4. So sine 3x sine 2x. The formula is in terms of cos. The formula goes like this: cos c, this is your c and this is your d. Okay, 3x minus 2x minus cos of 3x plus 2x, and please use a curly bracket out here, into dx. We move ahead, 1 by 2, 0 to pi by 4. Is it cos x only? And minus, is it cos 5x? Now you know what to do. Integrate it term by term and put the upper limit minus lower limit. Finished. Isn't it or not? So that's very easy and simple question, provided we know this formula. Okay, so pause the video and note it down. Let's move to question number 13 part 1. Question number 13 part 1, the question is pi by 3 to pi by 4 tan x plus cot x whole square. Okay, this is the question. This is simple. Tan as sine by cos, cot as cos by sine. Take the LCM, you will be getting sine square x plus cos square x. Okay, so we know sine square x plus cos square x is 1. So therefore pi by 3 to pi by 4, this is 1 divided by sine x into cos x dx. Okay, now we need to simplify it further. So in order to simplify, I need to get 2 out here. So we don't have 2, so multiply with 2 and then divide with 2 as well, because this gives me in the formula 2 sine x cos x as sine 2x. So I'm writing this side. So pi by 3 to pi by 4, this is twice divided by sine 2x dx. Okay, and I know 1 by sine means cosec. 2 you can take it outside. 2 pi by 3 to pi by 4. This is 1 by sine 2x dx. So what is 1 by sine? Cosec 2x. So therefore 2 is pi by 3 to pi by 4. So this is cosec 2x dx. Okay, pause the video till here quickly. Okay, so this is the last step, integration of cosec 2x. We know integration of cosec x is log of cosec x minus cot x. So therefore log of cosec 2x minus cot 2x and divided by 2, because here x is 2x. This 2 and 2 gets cancelled out. So therefore we will be getting log cosec 2x minus cot 2x with the limits pi by 3 to pi by 4. So let us put the upper limit and then we'll put the lower limit as well. Okay. So therefore, in the box bracket, I'll be getting log. First, I'll be getting cosec pi by 2. Is it cosec pi by 2 minus cot pi by 2? All right, and then minus log of this will be cosec 2 pi by 3, isn't it? Log of cosec 2 pi by 3 minus cot 2 pi by 3. Let's close the box bracket as well, and then we'll clear this as well. Now we just have to simplify it. So let us simplify. Now cosec pi by 4 is 45 degree. So cosec 45 is root 2, cot 45 is 1, not a problem, but the problem is out here, isn't it? Let us see which angle is this. 2 pi by 3. Now pi by 3 means how much? Pi by 3 means 60. Pi by 3 is 60, 60 into is 120. Now cosec 120 degree, we need to find cosec 120 and then cot 120, isn't it not? So we can also use this formula, isn't it? So this is cosec 2 pi by 3. See, pi by 3, pi is 180. 180 by 3 is 60, and 60 into 2 is 120. So 120 degree. Cosec 120, I can write this as cosec 90 plus 30. Isn't it? Cosec 90 plus 30. So all sine, tan, cos. Isn't it? So 90 is out here. So 90 plus 30 and cosec. In the first quadrant, it lies in the first quadrant. In the first cosec is positive. So cosec changes to sec, isn't it? So this is sec 30 degree. So what is the value for sec 30? Sec 30 is the opposite of cos 30. What is cos 30? Cos 30 is root over 3 by 2. So this will be 2 by root over 3. And similarly with this is your cot 120. So cot of 90 plus 30. Okay, but yes, it does not belong to second quadrant. So therefore it's going to be negative. And cot changes to tan 30 degree. What is the value for tan 30 degree? Root over 3. So hence it is going to be minus of root 3. So we've got this value and this value and this as well as this value. So let's put the values out here. So therefore this will be log cosec 45 is root 2 minus 1 minus log of cosec this is 2 by root over 3 and minus, and it's already minus, so minus and minus, this will be plus. So let's simplify it further. I hope I can clear this now. Right, so therefore this will be log, okay, root 2 minus 1 and minus log, you can take LCM as root 3, so root 3 to root 3 is 3, so therefore this will be 5 by root over 3, and use the formula log A minus log B, which is log A by B. So when you simplify it, then we will be getting this as root 3 into root 2 minus 1 divided by 5. Let's use the box brackets, something like this. Okay, pause the video and note it down. Okay, so next one I'm taking is question number 17. The first line I've already done out here, because see, if I explain one by one, line by line, the video is going to be very lengthy. So I don't want to keep this video very lengthy, okay? Yes, x into e to the power x. Please go to the book, okay? Your question. So it's product of two functions, algebraic and exponential. Algebraic comes first, exponential comes second. So algebraic function is the first function and exponential is the second function. Use integration by parts. Integration by parts. Remember, we have done in exercise 8.11 integration by parts in detail we have done, isn't it? So therefore, yes, the same formula I'm using out here. X integration of e to the power x minus integration, use the curly bracket, differentiation of first function into integration of second function dx. Okay, let's simplify it further. The moment you finish it, put the limits as like this. Okay, and mention that integrating by parts. X integration is e to the power x minus curly bracket, it is 1 e to the power x dx it goes from 0 to 1. Very simple question, okay? E to the power x minus integration e to the power x dx, 0 to 1. This is again e to the power x as well, e to the power x minus e to the power x. It goes from 0 to 1. Now what to do? Put the upper limit and then the lower limit. So this side I'm showing it. So upper limit is 1, isn't it? So 1 e to the power 1 minus e to the power 1 minus 0 e to the power 0 minus 0. So therefore this is e to the power 1 e to the power 1. So e minus e, alright, this is already 0, 0, even this 1, e to the power 0 is 1, but 0 into 1 is 0 minus 0. So therefore e gets cancelled out, so the whole answer is how much? 0. So pause the video and note it down. There was one small mistake out here. When we put the value, okay, let's see once again what was the mistake. Okay, 1 e to the power 1 e to the power 1, fine. But when you put 0, 0 e to the power 0, sorry, this is also e to the power 0. This is your e to the power 0. Okay, please make the mistake out here. E to the power 0 and e to the power 0 is 1. So this is 0. Not a problem. E to the power 0, e minus e is 0, minus and minus will be minus 1, and now minus and minus will be 1, so hence the answer is 1. Okay? So please